increasing and decreasing, we need to state the domain and the range. And we need to state the positive and negative intervals, and then we need to state the rate of change over the interval -3, 0, right? So take a second and make a little legend up there for that stuff. Increasing, decreasing domain range, positive, negative. So what do we think about increasing?
It starts at -5 and goes to 8.
Okay, but remember with increasing, we only read the x. So from here to here, right? So remember, we don't want to say 8 because that's a y value. Okay, we want to say the x value. So here we would say what, -5 to 1 here, right? What about decreasing? Yeah, see how there's an arrow over here? So that means it's going to keep on going. So basically it starts decreasing at 1 and it keeps on decreasing, you know, forever. So basically we're going to say that's from 1 to infinity. What about the domain? What's the lowest value x can be?
-5.
Okay, do we include -5?
Yeah.
Well, there's an open circle there, so I think we better use a parenthesis. Okay, what about the biggest number to the right? Infinity, correct. And then what about the range? How low does the graph go? To negative infinity, right? Because that arrow right there is also going down, so it's going from negative infinity. How high does it go? 8. And we will include 8. Now, where is the graph positive?
Starting at -3 and going to 5.
So from -3 here to 5 here, the graph is positive. Okay, and then when is the graph negative?
So it's negative starting at -5, -3.
So -5 to -3.
It's negative again at 5 to infinity.
Okay, so then we need a union, right? And then over here at 5, it picks back up again. And all the way to infinity, it stays negative. So basically, remember how to read those values. Okay, use interval notation. And any questions on any of those?
So when it's a closed circle, that's when you use a bracket.
Yes, and the only place we really use those are on domain and range. We don't really use the closed brackets on any place else.
So when it's an open circle or a closed circle, you say?
Closed. Closed gets the bracket. So now they said do the rate of change from the interval -3, 0. So we have to get a couple points here, right? So -3 is a point there, and 0 is up to here, correct? So we have to write down our 2 points, which were -3, 0, and what was the other one? 0, 6. And so then we got to do the slope. So y2 minus y1 over x2 minus x1. So if I do 6, then I'm going to do that 0, right? 6 minus 0. And then I'll start with this 0 here. And minus a -3 means +3. So that rate of change should be, what, 6 over 3, which is then equal to 2, correct? So you have to know your slope formula and do it over the low part of the interval to the high part of the interval. And that's your average rate of change. Okay, so for this next part, we're going to list the transformations for the function up here. So that's basically a cube root function. So what's the first transformation we see? Reflect on x-axis. And what's the next transformation we see? Vertical expansion. By a factor of 2. And then the next thing we do is what? Shift right 3. What's the last thing we do? Shift up 2. Okay. And you know, you can say right 3, up 3. You can say, you know, you can abbreviate some of that stuff, like vertical expansion, you can abbreviate it. Like if you're short on space, it's not sure. I can tell. So now we're going to do a piecewise. So basically, this has 3 parts. I'll do the first one in blue. I'll do the second one in green. I'll do the third one in red. And so we need to be able to graph this, and then we'll do it in decimals. Okay. So get your laptops out. Make sure you got that available so you can do stuff in decimals. Okay, so the first thing we do is we look at the condition. Okay, so x has to be less than what? -3 for that piece of that picture to show up. Okay, so that thing's going to the left, right? That means you have to draw it backwards. Okay, and sometimes it's hard to count slope backwards, but you have to practice that. So I'm going to say fine. Ordered pair here starts with a -3, right? Is it going to get an open or closed circle? Open circle, correct? So now we're going to plug -3 into that x. So when we plug 2 times -3 minus 1, what's that give us? -7. So now -7, so -3, -7, and you can draw this in the lower left on your graph. See your paper there? I have a graph down there in the lower left. See it at the bottom? You can use that right below number 6, use that. Okay, that way you can draw. So I'm going to put -3, -7 on here. And it's going to get an open circle, isn't it? Now, what type of slope does that line have? What's the slope of this line up here? 2, right? Remember, that is y equals 2x minus 1, correct? That's what it is. So it's got a slope of 2. Now, if I go up 2 and right 1, that's incorrect. It's a positive slope, but I can't go to the right. I have to go to the left. Okay? So that means I have to go down 2 and left 1. And that's what I'm drawing. So remember, if you have to draw left, you have to draw backwards. Now, look at my arm. You know, isn't that a positive slope there that I just drew? It's going up from left to right, isn't it? That's a positive slope. Now, the next part we're going to draw is just y equals 4, right? And so we're gonna draw that from -3 to 1, correct? And -3 is gonna get a closed circle, and 1's gonna get an open circle, correct? So I'm looking at this condition. So from -3 to 1, when I plug it in, what can I write down? What's my output here? What's y supposed to equal? 4. There's no math to do. Okay, it's just a horizontal segment, right? So now I need to plot those 2 points and then connect them. Done. So -3, 4, which is here, and 1, 4, which is here, and then I just connect them. Now notice if I would have drew into, like, if I would have put a point like here and kept going like this, that's going to fail the vertical line test. Okay, that's why I couldn't do that. Okay, you have to sort of imagine that there's a barrier there, some type of invisible barrier. You have to imagine like there's a barrier there, and that's a critical error. Okay, that's the way you go. And what's the last thing we're going to draw? We're going to draw y is equal to what? -x plus 2. And we're going to draw that for x being greater than 1. So we're going to put a 1 here. It's going to get an open circle, isn't it?
So how do you know the circle's open or closed?
Because there's no arrow, the arrow has no equals underneath.
Okay,
So it doesn't include it. Yes. So now when we put a 1 in here, -1 plus 2 is what? 1. Now I'm going to draw this open circle at 1, 1, correct? And then my slope is what? My slope's a -1, isn't it? So that means I'm going to go down 1, right 1. It's okay to count forward because I'm going to the right, aren't I? Now Desmos will help you draw this, but it won't help you with open and close. You have to figure that out on your own. So now go to Desmos, and we're going to put in all 3 equations. Okay, so now when we go to Desmos, do I have Desmos up here anywhere? Yes, I do. There we go. So the first equation that we just drew, hold on a second, I need a thing. So that's going to be y equals 2x minus 1, right? So you're going to put in y equals 2x minus 1. And then you're going to have to bring up a brace. So you're going to hit the ABC button and bring up a brace, and then go back to your 1, 2, 3 button, and you're going to put in that inequality. Okay, it says x is less than a -3, right? And then you can hit down. And see where it drew it at down here? You can see barely that it drew a little segment of that. Now, you can hit minus and zoom out a little bit if you want, just depending on where you're at. But you can see where it drew it. Does it look like what we drew on your paper? With the exception of what? You don't see the open circle, right? You have to do that. Okay, let's go to y2. We're going to put in there what? Y equals 4. And then we're going to bring up a brace. And we're going to put in -3. Let's say less than or equal to x less than, so let's say 1. That look like we put on your paper? Except for what? Open and close, right? And then for the last one, we're putting in y equals negative, what is that, x plus 2. And notice how it's going to give you the whole line unless you restrict the x, correct? So now we're going to say fine, restrict it to be x is greater than 1. And that looks like what we put on your paper. So you can use these to aid you, but it does not replace the brain, does it? This just keeps you from drawing backwards. Okay, now, take your pencil vertically across the screen, right? Does that pass the vertical line test? Okay, where's the only places it's tricky? Here, right? And here, that's when you need to open or close stuff on your paper. Because if you don't have open or closed on your paper, then that will be incorrect because it'll have to be closed, right? You have to specify open, okay? So that's that. And that's how you do piecewise function manually and technologically. So now, number 4 is another decimals problem, right? So the left-hand side, put it in, the right-hand side, put it in. Go ahead and try those. So again, you'll graph this part first, and then you'll put this in the other one. Don't put them both in the same line. They got to be in different lines. So we're going to say, what's that say, 0.25 x plus 3. And then in the next one, we put in x squared minus x plus 2. Now, what are you looking for? Where they're crossing, you're looking for the x values only. Okay, because there wasn't an x and a y in this problem, was there? Okay, so basically, you're just going to test the graph. So that first x value is negative 0.554. That's your first estimation, right? Your second x value is 1.804. How many answers did we get? You got 2 answers. Make sure you have them both listed. Okay, this is sort of all or nothing, right? You either write them down or you don't write them.
So during the quiz, will we find some on decimals too? Or?
Yeah. Well, I'm showing you this, and then I'm going to take away the opportunity. Just a second. Okay, so now let's do 5. Go ahead and type 5 in decimals now. So what shape does that make? It's a parabola, right? Now, what's the condition? Less than or equal to 0. So in this case, since they said equal to 0, you would need to use brackets, right? For the one side of it. Okay? But when is it, if it's saying when is this not positive, isn't that what that's saying there? So look at your picture. You're going to say from negative infinity to negative 5, right? And you're going to say from, what is that? From 3 to infinity, aren't you? Okay. Well, what happens if you put the less than or equal to in here? 0. What happens to your picture? Now the picture is no longer parabola, isn't it? Now it's just giving your solution. Okay. It's just giving it to you two-dimensionally. Okay, normally we would just say this is at one dimension. Okay, so basically, are they including -5?
Yes.
Yes. Are they including 3?
Yes.
Yes. So that's why they would get the bracket. Okay. So when we see something like that, we're going to say, fine. We're going to say it's going from negative infinity to, what was it, -5? And then it's going from, what was the other number? 3 to infinity. Now, if that little line wasn't underneath there, then we would just use parentheses, right? But since that line was underneath there, we had to include it because it was also keep that.
So what was the answer for again?
The 2 points that we said, the x values, the 2 x values. And those 2 x values were -0.554, and what was the other one? 1.804. It was just the 2 x values, not the 1. Now, again, with 6, you're going to do the same thing you did with 4, right? They're just putting function notation on it. So the f of x goes in, and then g of x goes in. So now, we're saying what, x squared minus 8x plus 5. And we're saying x plus 3. Now, how many times does that line cross that parabola? 2. So you got to give me the x values of both of them. So notice how that intersection and that y-intercept are really close together. So be careful, right? So that's going to be the x value, correct? 0.228. That's going to be the x value up there, 8.772. That's just, can you read decimals? Those types of things. Keep in mind, we have to understand that's what equality means when we deal with more than one equation where they cross. All right, now we need to graph this. And again, you can graph it by hand and you can graph it using decimals, right? So the first equation should be y is less than a negative 2x, what was that, plus 10? Yes. So that's going to be dashed, isn't it? We're going to draw a dashed line for all of these, really. All of these will get dashed lines. Okay. So I'm going to start at 10, and my slope's a negative 2, isn't it? Oh, that's a 9, isn't it? So I got to go a little bit above. Yeah, I'll have to call you back, brother. So basically, that's a dashed line. Now, is this less than or is this greater than? What's the arrow telling us? Telling us less than. So you're gonna just pull down on this, but we're not gonna draw that right now. We would shape down on that, right? It's less than we would pull down from where we drew the line. So let's hold on. Okay. Now, this next one we'll do in blue, but we need to solve that, correct? So that says x minus 2y is less than 8. So that means negative 2y is less than negative 1x plus 8. Then divide negative 2, divide negative 2, divide negative 2. Y is greater than 1/2 x minus 4. What did I change the inequality symbol? Divided by a negative. So anytime you're solving for y and your y is negative, be very careful. Okay. Now in this case, I'm going to be at a negative 4, and my slope is a positive 1/2. And again, is this a less than or a greater than problem? It's greater than, isn't it? So then we would pull up. Okay, remember your common region is going to be your solution. So you don't want to scribble and read the snowstorm. Okay, you want to get an idea of where you're going with it. Now, the other one says that x has to be greater than 0, right? So that means you're a vertical line at, and that means you're graphing in this way. And this last one here, I'll do it in a different color. We'll pick this. We'll pick this. Perfect. Okay, so now we're going to say that y is greater than 0. So that's horizontal, correct? And that means you're going to shade up. So what's their common intersection region is going to be what? This little area in here, basically. Isn't that going to be where all the arrows are going to? Now this arrow down here gets lost in the sauce, doesn't it? Because of this purple arrow. So basically this is just your common shaded area. Okay.
Is that where if you put it on decimals, all 4 colors would be passed?
I just put it in decimals right now. Take it, just type each one in a different block and look at it.
Yeah, no, that's what I'm saying. Like, because all the colors will be in that one spot. Like,
Yeah, exactly. It's sort of like X marks the spot. That's the region where they're all true, right? And that's really what inequalities are about. They're about being true or being false. So go ahead and put it into decimals. And so we had y plus what, 2x was less than 10. And then you have the next one, which was x minus 2y was less than 8. And then you had x greater than 0. And then you had y greater than 0. And you can sort of see it's that little triangle in there where they all 4 hit. You know, that's what you can see. So again, I showed you by hand and I showed you in decimals. Now, there's a couple here we got to work that aren't on your warm-up, so turn your warm-up over and write this down. I'm going to pause the video. So we have to sketch the graph of a polynomial with a negative leading coefficient. So that means A is negative, and zeros, so x is equal to 0. And then x is equal to a negative 3, and that has a multiplicity of 2. And then x is equal to 2. So basically, we can write those factors now. Okay. Now, x equals 0 means you're going to say x minus 0, which is just going to say, you're just going to say x, correct? Nobody says x minus 0. X minus 0 is x. The next one's going to be what? X plus 3. But then we have to square it, don't we? Because that's a multiplicity of 2. And then the last one's just what? X, what is that? Minus 2. So I know that y should equal a negative takes care of the a, correct? And then x, and then x plus 3 squared, and then x minus 2. Now, if your binomials are switched, that's fine. Okay, but you should lead with your negative and you should lead with your monomials. Okay, it's just okay. Now, what's the total power of this problem? It's right, it's got a 4 power, doesn't it? So it has a power of 4 because this is 1, this is 2, and this is 1, right? So all those add up to make 4. So that means it's even, isn't it? But a is negative. So that means my arrows should go down, shouldn't it? Now I know that I have a 0 at negative 3. I know I have a 0 at 0. And I know I have a 0 at 2 because that was the stuff that was given to me, wasn't it? Okay. Now, it's going to be going down in the end, right? Now, how does it go through negative? It bounces, doesn't it, right? So we're going to come up here, we're going to bounce, and then we got to come back and what? Go through that linearly, correct?
Yes.
And then we got to turn around and go through this. Okay.
So if it's a positive 3, you would bounce off. If it's a negative.
No, it's bouncing because of the multiplicity of 2, not because of plus or minus on it. Now, my end behavior, because it's even, correct? And it's going downward because it's negative. My multiplicities were 1, 2, and 1 respectively. So I went through and I bounced at the one that had a multiplicity of 2, and then I went through linearly at the other 2. Okay, take a minute and write this down. I'm going to pause the screen again. Now we're sketching a graph of a polynomial with a positive leading coefficient and zeros of negative 4, 0 has a multiplicity of 3, and 3. X is equal to a negative 4, A is positive, X equals 0, multiplicity 3, and then x is equal. So these are all my conditions. So I can just really say, okay, fine, y is equal to, and then this one's going to be what? X plus 4? The first one's going to be x plus 4, yes? Because we got to move the 4 over and equals positive, yes? And then x equals 0 means it's just going to be x. And it has a multiplicity of 3, so that's going to be 2. And then the other one at the bottom is just going to be what? X minus, what is that? 3. So what are the sum of the powers on the side? 5, right? Because there's a 3, then there's a 1, and there's a 1. So sum of powers is 5, which is odd, isn't it? Odd, and A is positive. Correct? So that means my end behavior is going to have start low on the left and then high on the right. So somewhere down here, I'll have it going down. And somewhere over here, it'll finish going up. Correct? Now our zeros were -4 and then 0 and then what was it, 3? And remember, it's going to go through -4 linearly. It's going to disco dance through 0. And it's going to go through 3 linearly. So basically, if I think about it, when I start to draw this, it's going to start going up through here. And then when it turns, it's going to disco dance and then turn back around. So make sure when you're doing something to the power of 3 that you show that it sort of curves, snakes through it. Okay. That's the end of the warm-up video. But hold on a second. We got to go back. I forgot to do something in the warm-up. Oh, right here, I forgot to do this part. Very important we know how to do that. Okay, so let's go back and make sure we get that part. They said graph and then find that. Okay, so f of -2. So now, f of -2 is true in this interval right here. Okay, so that means we're applying it to this part of the function. It's not true in the top or the bottom, only in the middle. So f of -2 is equal to 4, because that's all it can equal, right? Now this part right here, -3 times, so we're going to say -3 times whatever f of 4 is. Well, notice f of 4 is going to be true for this one, so we're going to put 4 in here. Okay, so what happens when we put 4 in there? What's a -4 plus 2? It's going to be a -2, isn't it? Okay, so we're going to say -3 f of 4 is going to equal a -3 times, what did you just say the output was? -2? So what is a -3 times a -2? 6. So we ended up saying what is 4 plus 6, basically, right? So they're telling you how to evaluate it, so that's how you evaluate. Piecewise is very particular. You got to be in the right row. You can't use more than one row because it's only true in one area. It has to pass the vertical line test, so it can't be in 2 places at once. Just like, all right, now the video.